So in this video we would see implementation of ensemble techniques using bagging mechanism. Okay, so at first these are the libraries we have to import: pandas, numpy, matplotlib, pyplot, sklearn, sklearn.svm. We have to import svc from there, then bagging classifier from sklearn.ensemble, and tenter split from sklearn.model selection. Let's run that. And now read our csv file. So read csv set.csv. Okay, these are our data sets. Now simply what you do, let's check how many columns and how many rows we have. We have 100 rows and 11 columns. Now again, let's set our input data that we would use. And actually the code should be lots of similar to our random forest, so don't waste that much time in here, or just copy this from random forest to bagging. Okay, then again we would change our diagnosis column into 0 and 1. This diagnosis column we would change it to 0 and 1 with the using the condition applied key. If we see hypertensions, obesity and overweight, then we would change those rows into 1, otherwise it would be 0. Okay, now diagnosis, let's see how many 0 and 1 we got. So we have got 63 zeros and 37 ones. Now again, simply we would make our x and y. In x we are dropping our diagnosis column so that we had only age, blood pressure, cholesterol levels, heart rate and BMI in our input, and in output we want our diagnosis. Okay, now simply divide our data set into train and test. So for that, x train, x test, y train, y test, v train, test split. We're simply passing the parameters of x, y, and test size would be, in this case, 20%, mean 80% for training and 20% for testing. Now process 1. In this process we would simply call our bagging classifier, and as you see in the cell where we import libraries, we have imported svc, means support vector classifier. So we are using support vector classifiers in our individual trainers. So our individual model has been trained using svc model. Now k-fold selection dot model selection dot k-fold, and we are splitting our training data sets into 10 subdivision. Now in results, selection dot cross val score model X trend, Y trend, CV would be k-fold. Now simply run this, and after training our bagging classifier, if we print our results, we would see that for each and every 10 subdivisions, each and every subdivision has been trained using SVC, but majority of the model is giving us 75% of accuracy. Okay, now if we simply min of these results, we would have results dot min. This would give us, sorry, min, it's a function, so 65. So 65 is our average training accuracy using SVC on this particular data sets. Okay, now if we use our second process, where again simply calling the bagging classifier and then simply fitting our X trend and Y trend. Mean in this case I am not dividing my training data sets into 10 subdivisions. And now let's see how much accuracy I'll get. So I forgot to give the algorithms to be SVC. Okay, now let's predict Y pred p model dot predict X test, then simply print our predicted values. It is all zeros. Now calculate our score with respect to X test and Y test. We are having 55%, which is not really good. So for that we are using this function exactly after our process 2. So after this, if I run this again, I might get a bit more better. Okay, now let's simply print the classification reports and confusion matrix. Classification report and confusion matrix. So how to do that? Print classification report with respect to Y test and Y pred, and also confusion matrix with respect to Y test and Y pred. Okay, so the accuracy we are having is 0.65, and that's it. That's a simple example of using bagging mechanism for Ensemble Learning. We could use random forest like a decision tree, logistic regressions in place of SBC. Okay, so thanks for watching. Let's see in the next video.